Hello everyone. Today we will be finishing up our discussion of weighted voting with two concepts that are going to help us out with weighted voting systems, and those are subsets and permutations. So starting with subsets. A subset basically is just any, as the name implies, any set of the different elements within a set going anywhere from none of them all the way to all of them. So let's say we have a three-player weighted voting system where our players are P1, P2, and P3. This we would say is our full set, and when we're looking at the subsets, we can go from anywhere from 0 elements of that set, so we would indicate this with just a pair of empty brackets. We can have one of those three players, so just P1, just P2, or just P3. We can have 2 out of the 3, so 1, 2, 1, 3, or 2, 3. And finally, we can have all 3 of them. So this would correspond to the grand coalition when we're dealing with weighted voting. Now, how do we figure out how many subsets we're going to have when we are dealing with a weighted voting system? Well, as it turns out, the number of subsets that we have is always going to be equal to 2 to the n when we have n elements or n players. So in this case, we've got a 3-player system. So 2 to the n, that would be 2 to the third, or 8. This is why whenever we are dealing with larger weighted voting systems, listing out all of the different possible coalitions can get very complicated and very difficult very fast. Let's say that we had a 4-player system. We would have 2 to the 4th, or 16 subsets. If we had 5 players, that would increase to 32, and so forth and so on. Now, how is this related to or relevant to coalitions? Well, as it turns out, when we're figuring out the number of coalitions in a weighted voting system, we can actually just look at all of the different subsets minus this empty subset right here. So we would say that our number of coalitions is going to be 2 to the n, which is our number of subsets, minus 1 for the empty subset. Now, when we're dealing with bonds-off power, we're assuming no dictators. Therefore, we can't have a winning coalition with only 1 player. So in this case, we're only interested in the coalitions with 2 or more players. So we would say 2 plus player coalitions. And the number of these that we have is basically going to be the number of coalitions minus the number of 1-player coalitions. So we're always going to have n 1-player coalitions because these 1-player coalitions just pick one of the n players, basically. So the number of 2 plus player coalitions is going to be 2 to the n minus n minus 1. The other concept that we'll discuss today is what we call permutations. Permutations, when we have something like a weighted voting system, this is basically just going to be an ordered listing of the elements in the set. So sequential coalitions, which we use for calculating Shapley-Shubik power, are basically just permutations of all of the players in the weighted voting system. So if we're looking at a 3-player system, these are all of the different possible ways that we can order our 3 players, P1, P2, and P3. Now, there is also a systematic way to figure out how many permutations we're going to have, and that is n factorial, which basically just means we're going to multiply n by every integer on all the way down to 1. So in this case, we have 3 players, so 3 factorial, which is 3 times 2 times 1, which is 6. One thing about factorials is that they get really big really fast. So 4 factorial, for instance, is 24 already a big increase from 6. And then when we get to 5 factorial, we now have 120, and it just keeps getting bigger and bigger, of course. So this is why dealing with sequential coalitions and Shapley-Shubik power for weighted voting systems where we have a lot of players can get really complicated and really difficult really fast. Thank you for watching, and of course, if you have questions, I am always happy to help.